Welcome to the Deep Dive. Today, we're tackling a concept you might have heard tossed around in physics: spin. Now, if you're picturing tiny balls actually spinning, well, the material you shared suggests we need to think again. Our mission here is to unpack what spin really is, why it's so crucial in physics, and maybe even challenge how we think about reality itself. Ready for a bit of a mind bender? Okay, so let's kick things off. How do we, as humans, start to understand the universe? The research you sent points out something fundamental. We have to divide things up. We separate the world into an apparatus, like our measuring device, and the environment, the thing we're measuring. That's basic science, right? The scientific method 101. But does that mean our view is always sort of filtered?
Exactly. That's the starting point. And then, well, to actually describe those measurements, to do the math, we need more distinctions. Think about the difference between 0 and 1. It sounds simple, but it's a conceptual split we impose. And it's this whole process, this making of distinctions, that leads us to see things like particles, these apparently separate things existing in an environment.
Right, okay. And it's when we look closely at these particles that this really interesting property shows up: spin.
That's it. And observationally in nature, we primarily see two kinds. There's what we call half-integer spin. That's the signature of fermions, think electrons, protons, the building blocks of matter. Then there's integer 1 spin. That belongs to bosons, photons, for example, the particles that carry forces. We also see things with no spin, sure, but the action is really with these half-integer and integer 1 types.
But here's where it gets really interesting and a bit strange. What about integer 2 spin? Mathematically, the equations seem perfectly happy with it. It fits the models.
Oh, absolutely. The math allows for it.
But this is the kicker from the sources. There's just no proof in reality. We haven't found anything with spin 2.
Not a single particle, nope. Despite, some physicists hoping might eventually find it.
So for this deep dive, we're sticking with what we actually see. Half integer for matter, integer 1 for forces. It really makes you wonder, doesn't it? Why does reality only use some of the mathematical options?
And that brings us to a really, really important point. We use numbers, we use algebra to sort of mimic spin on paper. We model it. But in the real world, something actually has spin. And for something to have a property like spin, well, it has to exist, right? It has to be made of something. And crucially, the sources argue, it must have a shape.
Shape. That's a fascinating way to put it. Not just a number, but a physical property related to shape. So even though particles are different, electrons, photons, whatever, they share this fundamental shape property we call spin, which leads to the big question the sources raise. What is it about the shape of a particle, or maybe even the shape of space-time itself, the very fabric of reality? What gives rise to spin? What does it actually look like? If math only mimics it, how do we find the real thing?
Yeah, and when we say shape, we need to be a bit careful. It's probably not like a little sphere or cube we can picture easily. It's more about the underlying structure, the configuration, maybe the topology, something inherent, something about the particle or reality's fabric that just results in this measurable quantum number we call spin. And this is where the sources really critique the current approach in physics. Why are we so focused on finding mathematical symmetries, these abstract patterns in equations that act like spin? And then just declaring those patterns to be spin instead of, searching for the actual physical shape or structure that causes spin. It's like being satisfied with reading the menu instead of asking what the food is actually made of.
Okay, so pulling this all together, the sources seem to be suggesting something quite profound, that maybe we humans overestimate our ability to carve reality up with our concepts. We assume reality has to fit into our boxes, zeros and ones, apparatus and environment. What if it doesn't?
Well, connecting that thought to the bigger picture leads to a really radical idea. What if, fundamentally, in reality itself, there are no distinctions? Think about it trying to truly separate one part of a flowing stream from another. It's all one continuous thing, isn't it? The sources propose that the machinery, the material, the fabric of reality might be one thing that can still produce the view of many local things that seem separate. The idea that everything we see is distinct is just maybe ripples on a single unified ocean.
Wow, and that loops right back to spin, doesn't it? If we start thinking about the shape of reality itself as this unified fabric, the sources suggest that understanding that shape might naturally explain why only certain spin values, the 1 and 1/2, actually show up.
Exactly. The allowed spins might be properties of the fabric itself, not just arbitrary mathematical possibilities. And this whole new way of looking at things at distinctions, the in-betweens, the machinery of reality, and how it might unlock new physics. It's the focus of research outlined in the sources. If you're curious, there's a book mentioned, New Perspective, on distinctions, in-betweens, machinery, and new physics, available on dstakel.nl that goes into it.
So this deep dive really points towards a potential shift in perspective. What if spin isn't just a quantum number, but it's tied to the literal shape, the structure of reality? And what if that reality is fundamentally unified, way more connected than our scientific habit of making distinctions leads us to believe?
It really pushes us to question assumptions we often take for granted in physics. If we start thinking about reality not as pieces, but as a whole, a single indivisible fabric, that could change, well, everything about how we understand the universe, from the smallest scales to the largest.
So let me leave you with this thought. What stands out to you about this idea? The idea that reality might be one unified fabric, not just a collection of separate parts. And how might thinking that way change how you view the cosmos around us?